Hello and welcome back. Okay, I believe in the last video I introduced us to differential equations. So today we are going to be learning about the order of differential equations, degree, how to identify the dependent variable in a differential equation, how to know the independent variable, and how to decipher or how to check if differential equation is either an ordinary differential equation or a partial differential equation. So we're going to take some examples and discuss about them right now. Okay, sorry, let me clear this. All right, now assuming I have a differential equation like this equal to 3x plus 1. Okay, so let's label this differential equation. So starting with the order, what is the order of this differential equation? Now the order pertains to the derivative in the equation. The order of a differential equation is actually the highest derivative present in that differential equation. Take note of the word highest derivative. Okay, highest, and I'm gonna repeat that again, highest derivative present in that differential equation. So for this particular differential equation, the order is actually first order. So why didn't I say the order is dy dx? Remember, the order is the highest derivative. So by the highest derivative we mean like in terms of position. Okay, the highest position of the highest derivative, highest position. So we are having dy dx here. So this is actually the first position or the first stance of differentiation. So this is actually a first order differential equation. Okay, so you differentiated it only once, so this is first order. And let's go to the degree. We'll see more about order to drive home the point. Now for this particular differential equation, how do you identify the degree of this differential equation? The degree of the differential equation is actually the power of the highest order, the power of the highest order. So you go to the highest order, which is this first order derivative term here, and you can see that there is actually an invincible one. Is that okay? There's actually an invincible one. So let me reverse it, and you can see that before I put those braces, you agree with me that there's an invincible one surrounding this whole derivative. Okay, there's an invincible one surrounding this whole derivative. Sorry about shifting of screen. So this is our first order derivative, and the degree is also degree 1. Okay, 1. So our first degree. Now we'll go to what is the dependent variable. So the dependent variable is actually the variable in the numerator of the derivative. Okay, I have numerator and denominator. So anytime you see the numerator of a particular differential equation or a particular derivative, okay, just check the derivative, whether it's first derivative or second or third. You're just looking for the letter in the numerator position, which in this case is y. So the independent variable is actually independent is actually the variable at the denominator position. Okay, so you normally hear me saying derivative of y with respect to x. Okay, so whatever your derivative is with respect to, that is your independent variable. But simply put, you can easily find it by looking at the variable at the denominator position, which in this case is what, x. Then what else did we talk about? Is this ordinary differential or is this partial differential? So ODE, yes. PDE, no. So this is actually an ordinary differential equation because we cannot see this partial operator over there. Okay, so is not in this particular equation. So the partial operator, the del operator, is not here. We just have the deal operator present. Okay, so this is an ordinary differential equation. I hope we understood very well. So I'm going to take 2 more examples, and that'll be all for this one. So assuming I come up with something again, let's identify this one. So you have y plus 3 dy dx plus 6 d squared y by dx squared is equal to x squared, for instance. So let's label this. So of course, the order, what is the order of this differential equation? Remember what we said, it's actually the position of the highest derivative, and the highest derivative is actually occupying the position of 2. So this is the second order, okay, derivative, second order. So the degree is the power of the highest derivative. Okay, so we have the 2 y by dx squared as the highest derivative. So the power surrounding this particular term is also 1. So this is a 1 degree, second order 1 degree differential equation. So the dependent variable, the v, is actually y in the numerator position, then the independent is x again. So we have our ODE or PD, yes, PDE, no. Is that okay? So these are actually the properties of differential equations. You need to know the order, the degree, the dependent variable, the independent variable, if it's an ordinary differential equation or a partial differential equation. Okay, so let's take another example and I'll call it a day. So this one might be a little bit more complicated, but we'll get to it together. Let's look at this one. So assuming I gave you something like what I gave you in the last one, let me just come up with something again. You have the 3y by dt squared raised to the power of 4 and plus the y dt raised to the power of 3 minus the 4y by dt squared and raised to the power of 2 and plus 3y squared is equal to sine 2t plus 5, for instance. Okay. This one looks a little bit complicated, but let's do it together. So we have, first of all, the order. So the order is still the same definition. What is the highest derivative? What is the position of the highest derivative? Oh, there's a mistake here. The highest position of the highest derivative is actually 4, right? So this is fourth order DE. So this is fourth order differential equation because we are looking at the highest position or the highest level in which this differential equation was differentiated, and the degree is actually the power of what the highest order. Now some of us might be tempted to say 4, but 4 is not actually the degree, or 4 is not actually belonging to the highest derivative. 4 is belonging to the second highest. So the degree of this differential equation is not 4, it's actually 2. So we have 2, so 2 degree. Okay, differential equation. Now the independent variable in this case is actually what, yeah, you got that right, still y. Then the independent variable is actually what, yes, you got that right, so that's t in this case. So the independent variable with respect to what, so in your normal functions you discover that the sign of whatever we want to obtain, it actually depends on what t is. So the value of this sinusoidal function over here depends on t itself. The derivative also is with respect to t in each case. So the independent variable is t. Then we have, is this ODE or PDE? So ODE, yes. Then PDE, no. Okay, so this summarizes this particular one. Yeah, so let's proceed. So we're going to look at the last example together. So for the last example, assuming I have something like this, so partial derivative x plus del 2u over del. Alright, then is equal to x squared y squared, something like this. So I'm going to check the order, the degree. I'm going to check a dependent variable, independent. I'm going to check is it ODE or is it PDE? Okay, so first of all, the order is actually of course the highest derivative. Okay, the position of the highest derivative. So the position of the highest derivative is 2, which is a second order. So you have to scout through the equation to spot the highest derivative. Okay, so that's how you get your order. So the degree is the power of the highest derivative. So both this one and this one are actually containing the highest derivative terms, and of course they're both having the power of 1. So yeah, so this is 1 degree. Okay, then independent variable clearly is u in this case. So independent variable, so we have 2 independent variable, x and y. Okay, so we have x here in this particular term and we have y in this particular term. So these are the independent variables. So is this an ODE? No. Is this a PDE? Yes, because of the use of this particular del operator. Okay, the del operator. So this brings us to the end of this video. Thank you for watching. I hope you've learned about how to identify the order, the degree, dependent variable and the independent variable. So leave comments in the comment section in case there's something you don't understand. I'll explain it more on another video. Then in the next video we'll learn how to form ordinary differential equations, and we'll keep learning how to solve ordinary differential equations. Remember, I established that the focus of these lessons is on ordinary differential equations, so we may not do much on partial differential equations for now, but that one will be later in the future. However, we may borrow some techniques from partial differentiation to solve some problems. Okay, so see you in the next video. Don't forget to like, subscribe and hit the notification bell to stay updated on more videos coming up. So thank you very much. Have a nice day.